UM. All right? So, as I mentioned before, today we are being a little bit flexible with our technology, being that my projector just went out. I already sent a ticket out so they can fix it. So we're going to be working straight out of Nearpod, and since I'm an expert at this, I'm going to be using your screen to write to you what I'm explaining over here. Let's go. So you're like, wait, so I can't be on YouTube? No! Make sure you stay focused. So warm-up number 52 should be on your screen. You have problems number 1, which is write the compound inequality. Number 2, solve the equation, rational equation. Number 3, write the equation to the function. And number 4, identify the inverse of that. F of x equals 3x plus 2. So I'll give you guys some time and go. All right, here we go. For the sake of time, Jesus is going to get us started with number 1. So, Jesus, question. Are both graphs intersecting? No, they're not intersecting. That means in the empty space in between, what do we write? The word or. That is correct. All right. So, on the left side for the green shading, give us an inequality, Jesus. S is less than negative 2. Hands if you agree with that. That is correct. Why negative 2? Well, here's 0. And then we go 1, 2 to the left. And then it's an open point, so no equal sign. Okay. How about the red one? Tell your neighbor the red one, guys. And then here's who's going to pass someone. The red inequality. Red inequality. All right, pass someone. Mario. All right, so let's start with the number 4. Here's number 4. What is all this? That represents what? No. What is all this shading representing? X. Okay, so now, what is 4 compared to all those numbers for x? Less than or equal to. That is correct. Hands if you got that. All right, and once again, just for the sake of set notation, just do solution set of x such that, and then close your set notation. All right. For number 2, we cross multiply. Remember the 1, we can write it as 1 over 1. Is that correct? So that we end up with x plus 5 equals 2, x squared plus 5x. All right. And from there we get everything to one side. So I do minus x minus 5 minus x minus 5. And we end up with 0 equals x squared plus 4x. This is an x. And then minus 5. So negative 5 and positive 4. What two numbers multiply to give me negative 5? And when you add them, give us positive 4. Pass someone, Mario. Sammy, what two numbers multiply give us negative 5 that when you add them give us positive 4? 5 and negative 1, so my factors are x plus 5, x minus 1. Thank you, sir. And we solve by setting them equal to 0, x plus 5 equal to 0, x minus 1 equal to 0. So we end up with minus 5 minus 5, x equals negative 5, plus 1, x equals 1. Hands if you got that by yourself. All right. Next, I need a function for number 3. So I write y equals mx plus b. I need to rewrite this, y equals blank x. All right. So what is my y-intercept? Tell your neighbor, y-intercept, or plus b. Then Sammy's going to pass someone. Geo, y-intercept. Positive 5, very good. And now we need a slope. So here's positive 5 right here. I'm going to place another point right here. So tell your neighbor the slope, and then Geo's going to pass someone. Slope. Mariah? All right, Mariah, what is the slope for these 2 points? -3/1. Looks about right. Let's see, 1, 2, 3, and 1 to the right. And then we just rewrite that in function notation. F of x equals -3x plus 5. Let's go. How are we doing? Good? Yes? All right. So, let's see. Let me make some space. Everybody got those 3 already? Yes? All right, let me close notation, and let me start this over again. Oh, my goodness. Bless you. Bless you. I'm going to make some space on top over here. All right. For this one, it says identify the inverse. So here goes the process. First, I'm going to rewrite this function, but instead of f of x, I'm going to change that to y. So I'm going to write it over here as y equals 3x plus 2. Follow along, please. Write that on your notes. For number 4, y equals 3x plus 2. Next, we're going to solve for x, which means what do I do next? Tell your neighbor. What do I do next to leave x by itself? Jesus, go. Subtract 2, subtract 2. So we end up with y minus 2 equals to 3x, and then divide by 3, divide by 3. So we end up with y minus 2 over 3 equals x. All right. So the process to identify the inverse, what was it, everyone? Change f of x to y, solve for x. However, here goes what makes it the inverse. Look up to the screen, to your screen. I'm going to switch these 2 variables. I'm going to switch them. Is everybody looking to your screen? Yes? All right. So that means instead of y minus 2, what do I write? X minus 2 over 3 equals y. This is what we call the inverse. But we need it in y and function notation, so I write, here we go, let me change to blue. I write x minus 2 over 3 equals f of x, but instead of just f of x, I'm going to put a little -1 right on the f so that we know that it's the inverse. All right? Let me send you a screen so you can send that to me. All right, some of your notes, please. All right. Copy the agenda, please. Warm-up number 48. Was it 48? 52, yeah, my bad. Warm-up number 52 instead of 48. And transforming functions. Today's home play, numbers 1 through 4. I'll show you the next slide, and it's not page 41. And this is 50 what? 52. All right. All right. So, your code for the home play for tonight, let me show that. The code is Q3HN9. Write that down on your notes. Q3HN9. 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 All right. And your home play looks something like this. And today we're starting with transformations. Let's go, Q. Oh, yeah, we got this. All right. So we got do the indicated transformation for the following functions, so A and B. And we got 4 of the graphs down here. You're going to be doing some transformations, and we'll talk about that in a little bit, all right? So get a Cornell note going, please. You don't need a Frayer model. And our objective for today reads, I can transform a function using different parameters. I can transform a function using different parameters. I can transform a function using different parameters. All right, y'all ready? So, with that said, we're going to be transforming functions. Do we know what functions are by now? Yes. That's why we don't need a Frayer model. So that means that for every output, there should be an input, yes, 1 to 1. And we did examples, non-examples for that. And we know why those examples are not, as a matter of fact, remind your neighbor why this is a function and why this one is not. Remind your neighbor, please. Why are those functions? Why is that a function and the other one not? All right, looks like Sebastian's got it. Rachel's got it. I see you, Rachel. Let's go with Elijah. Elijah, why is that one an example for a function? The same input has the same output. Specifically, which one do we look at? -2 and 3. The input is -2. The output should be 3. When it repeats again over here, yes, it has the same output. So, why is the other one, why is the other one not a function? Let's see. Help me out with this one. Ashland, why is that one not a function? Because on the last one, it should be a what? -2, 3. It should be a 3, and it's a 7. That is correct. All right. So, write this down in your notes. Parameter. What is it? A number that transforms a function into another function. Write that down. Parameter. A number that transforms a function into another function. Parameter. A number that transforms a function into another function. All right? Underneath that, I'm going to give you the first 3 parent functions that we're going to be using. Parent function. Which ones, Mr. Q? The first one that we've been using already, f of x equals x. Another one that we've been using but I haven't really formally introduced it is f of x equals x squared. And another one that we're going to be working with pretty soon already is f of x equals x cubed. Those are known as parent functions. Parent functions. So when we do things to the original function, which is the one that I'm giving you right now, as soon as we do something with numbers to it and we change it, it's no longer a parent function. We call that a new function or another function. And whatever the number that we use is called a parameter. For example, if I change the first one, check this out, look up to the screen. If I change the first one and I change just this being x and I write x plus 3. So it was x before and now it became what? X plus 3. So what do we call the plus 3? We call that a parameter. So as soon as we change the original one, it can no longer stay f of x. We need to change it to g of x. Write that down, please. As soon as we change the original one to something else with a number, we no longer use f of x, we use g of x, and the number that we use is called a parameter. A parameter. So, with that said, I'm going to change this next one. Instead of just x squared, I'm going to write x squared minus, give me a number, 4. X squared minus 4. So therefore, question, what do we call this -4, everyone? We call it a what? Parameter, because it changes the original by doing something with a number. So we no longer write it as f of x, we write g of x equals x squared minus 4. And one last one, this one, x cubed. Let's say I multiply x cubed by 5, and it becomes 5x cubed. What do we call the 5, everyone? What do we call the 5? Parameter, because we're changing the original by multiplying times 5, and we no longer leave it as f of x, we write it as g of x. So that's what we're going to be doing today, but I want to make sure that we understand what each parameter does, that you understand what we're doing with that, okay? So with that said, everybody has those, yes? All right, write the general rule that we're going to be using from now on. Write general functions rule, g of x equals f of x minus h plus k. General function rule, g of x equals f of x minus h plus k. That's the rule we're going to be using, okay? So write it down. All right. Once again, our general rule, g of x equals f of x minus h plus k. And we'll break it down in regards to what we're looking at there, okay? So with that said, to get started, just to recap, we went from y notation to what? F of x notation, yes? So that's why we now are in function notation. So we're going to focus on this one, but before we continue, we're going to actually graph some of these. This is example Q. So what we did, we printed out some handouts for you. So go get a handout next to the paper back there. Grab, and it should look something like this. I'll give you some time. All right. Everybody there? Okay, turn to the side where it says example Q, example Q. Look for example Q, write your name, date, period on the top right corner, so like that you don't lose your stuff. Okay. And we're going to need two different colors. We're going to need green and red. So if you have them, get those ready, please. All right. And of course, your pencil and the black one for the first one. So here we go. We're going to start here with the first table, this one right here, with x and f of x to fill that in. All right, so it reads, graph f of x equals negative 3x minus 1 using the domain negative 2, negative 1, 0, 1, and 2. So that means I'm going to substitute this value to get started. I'm going to substitute it in here for the x. So here we go. What is 3 times negative 2? Negative 6 minus 1. Negative 7. Write that in there, please. Negative 7. Go to the next one. Next value is negative 1. All right. Help me out with this one, Franco. Negative 1 times 3. Minus 1. Negative 1 times 3 is negative 3. Minus 1. Negative 4. All right. Next one. Elijah, 0 times 3. Minus 1. Negative 1. Okay. Next one. 1 times 3, everyone. 3 minus 1 is 2. And last one, 2 times 3 is 6. Minus 1 is 5. All right, let's plot these. Negative 2, negative 7. Negative 1, negative 4. 0, negative 1. 1, 2. And 2, 5. All right, and let's get our line going through those points. And since this is the original one that we started with, we're going to label this one f of x. F of x. All right? So far so good? Yes? All right. Next. Let me do, let's change colors to green. And here I want you to do this. I want you to write f of x, but then you're going to write plus, give me a number, 5 plus 5. All right? So, we're about to do a transformation, guys, to this original black function, okay? So here we go. Writing utensils down, look to your screen, please. So this is what I'm going to do. This green one, this one, it says that we're going to do f of x plus 5, okay? So what does that mean, Mr. Q? That means that, look up to your screen, whenever you have x being -2, you need to look for when x -2, the original f of x. So what was the original f of x when x was -2? It was what? -7. So therefore you're going to do, what is -7 plus 5? What is -7 plus 5? -2. Write that in there, please. Let's do the next one. F of x plus 5, but now we're looking at when the original f of x when x was -1. What is x -1? What was the f of x? -4, right? So what is -4 plus 5? 1. That is correct. +1. Next, f of x plus 5, we're looking at now at 0. So the original f of x when x was 0 was what? -1. So what is -1 plus 5? 4. That is correct. 4. All right. I'll give you a head start. Finish the last two, and then show your neighbor to make sure they got that. Make sure you write it on your paper as well. All right. Give us the last two values. Elijah, pass them one. Who? Joseph. 7 and 10. Hands if you got that. All right, so let's graph those. There we go. -2, -2. Do that in green. -1, 1. 0, 4. 1, 7. And 2, 10. Graph your line. Now this one cannot be labeled f of x because now we did a transformation, right? Remind your neighbor what we're going to label this one. What do we label that one? Yeah, g of x. G of x. That's our new transform function. So, are we there so far? So this is where I want us to understand what this transformation is doing, or this parameter. So, writing utensils down, look up to your screen. Let's see if I can guide you with this as much as possible. Here we go. So look up. So we started with our black function, which is our what? F of x. Is that correct? And we were given these original points, these 5. Look at them. Are you looking at them on your screen? Yes. Okay, there they are. And then we did a transformation according to a parameter of +5 for the green. Is that correct? And then we got these new 5 points. All right, so here goes a question. Think about this question. And by the way, does everybody have like a little person in your life? Some of you? That person that's always wanting your flaming hot Cheetos and play your games and want to go everywhere with you, right? All right, imagine that little person walks in, and then they're like, "What are you doing?" And like, "Oh, I'm doing a transformation." What does that mean? Well, the original function is the black one, and now the new function is g of x, which is the green one. So, to put it in their terms, remember, they're not good with positive, negative numbers yet. What would you tell them happened from the black one to graph the green one? Look at it. Think about it first. What do you think you're going to tell that person you do to the black one to graph the green one? Talk it over your neighbor. What are we going to tell them? What do we tell them? All right, looks like Renzo got it. I see you, Renzo. Gio's got it. I see you, Gio. Enrique's got it. I see you, Enrique. Of course, Julisa's got it. I see you, Julissa. Annette got it. All right, Annette. All right. So what would you tell that little person? Let's see. Let's go with Renzo. What would you say that we do to the original black graph to get this green one? You move them by 5. In which direction? Move them up by 5. Hands if you agree with that. So, on your paper, check this out. With blue, I want you to show that you're moving these up by 5. Up, 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 up. And that is correct. Whenever you add something like that plus 5, we go up by 5. So, guess what you're going to do now with red? On the red, I want you to write f of x minus 7. So check this out. I don't want you to fill this in. I want you to graph me the red transformation from the original black one. So before you do, talk it over your neighbor. Tell them, what am I going to do to the original black one in order to graph this new transformation, f of x minus 7? Tell your neighbor. What are we going to do to the original one? All right. So let's see, what are we going to do to all those points from the original black one? Let's go with Denise. What are we going to do, Denise? Let me rephrase that. If the green one was f of x plus 5, and you guys said we move each of the black points 5 steps up, what are we going to do for the red one? Lower them 7 down. That is correct. So I'm going to start with this point right here. Bring it down 7 steps. We go 1, 2, 3, 4, 5, 6, 7. This one, 1, 2, 3, 4, 5, 6, 7. This one, 1, 2, 3, 4, 5, 6, 7. This one, 1, 2, 3, 4, 5, 6, 7. And this one, 1, 2, 3, 4, 5, 6, 7. And you graph your line, and we label that g of x. So, conclusion. Let me use my writing utensil here. Conclusion. Whenever we either look up, what did we do for the green one, everyone? What did we do for the green one? Added. What did we do for the red one? All right, so here it goes. Let's write this down. Whenever we add or subtract to f of x, we move points up for the positive or down for the negative. Straightforward, yes? All right. So, send me your notes, please. So the green one, we said we got f of x, and we did plus 4, so we moved each point 4 steps up. So that means for the red one, what are we going to do for the red one, my team? For the red one? Down 4. So we go from here, we go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And we label that g of x. All right. Send me your notes or take a picture of what you did on your graph. Send that in, please. All right. From 1 to 5, I'll come to write you up to right there so far. 5, 5, 4 is okay. We got it. Looks about right. And once again, guys, I apologize about the projector. It's part of life, part of the show. Sometimes they throw a little monkey wrench in between, and that's how we need to keep rolling. Technology's got nothing on me. Let's go. Could have done this with my cell phones. Let's go.
The show must go on.
Yeah. Yes. The show must go on. Yeah, I like that. All right, let's go to the next one. Oh, on your notes, your actually Cornell notes, write this down. Right now we just finished with g of x equals fx plus k. So write this form down. I want you to write g of x equals fx plus k. Remind your neighbor what we call k. What is another name for k? What's another name for k? Enrique. Oh, you weren't here. You were actually stepped in at the end. Let's go with Mariah. What's another name for k? Before Mariah gives me the name, tell your neighbor what's another name for k. What's another name for k? Start with the letter P. All right, Mariah, what's another name for k? That is correct, parameter. Why? Because what is k doing right now? What did we just show? Positive, it goes up. Negative, it goes down. That is correct. And that's what you need to write there. Explain in your own words what k does. Positive goes up. Negative goes down. So whenever we substitute a positive number there, like a positive 5, it goes up. And if we substitute in there a negative 7, it goes down. Positive goes up, negative goes down. Okay. Pretty good, yes? All right. Move on. Turn your handout over. Let's go to the next one. All right. So we are here. In green, I want you to write f of x minus 5. And for this one, f of x plus 5 inside of the parentheses. So to get started, here goes. We're starting out with the function f of x equals x squared using the domain -2, -1, 0, 1, and 2. So let's begin. Look up. -2, we're going to substitute in here for the x. So that means -2 to the what? Second power. Is that correct? So what is -2 times -2? Positive 4. Next value, -1. If we substitute it in here, what is -1 squared? 1. What is 0 squared? What is 1 squared? 1. And what is 2 squared? 4. Let's graph our original f of x. Negative 2, 4. Negative 1, 1. 0, 0. 1, 1. 2, 4. And then you graph your curve like this. And we label this one f of x. All right, let me pause the music really quick in the back. So, now we're going to do a transformation, but I want you to notice, look up guys, who notices now that the x has a number inside of the parentheses with it? Does everybody notice that? Look at the green one. Turn your handout over to the other green one that we did in the back. Where's the number at according to f of x on the green one? Outside the parentheses, right? So for this one, the number is where? Inside of the parentheses. Bless you. So what does that mean, Mr. Q? That means this. Look up, please. That means that I'm going to take f of, I'm going to use the number 3. Here it goes. And substitute that in here, So watch. What is 3 minus 5? Everyone? Negative 2. But since we are doing what else? To the second power. So what is negative 2 squared? That is 4. Here it goes again. Next value, 4. If we substitute it in here inside of the parentheses, what is 4 minus 5? Negative 1. But then we take that to the second power. Negative 1 squared is 1. Next one, 5. What is 5 minus 5? 0. What is 0 squared? 0. Next one, 6. What is 6 minus 5? 1. 1 squared is 1. And then the 7. What is 7 minus 5? 2. What is 2 squared? 4. All right, let's graph that one in green. 3, 4. 1, 4, 1. 5, 0. 6, 1. 7, 4. Let's graph it. And we label that one g of x. So you're like, So, here goes the critical thinking question. Here it goes. Y'all ready? Here goes the question that I'm going to ask. Look up to your screen. If we start off with the original 5 points for the black f of x, this one, this one, this one, and this one, and a little person walks in and they tell you, what did you do to this one to graph it over here for the green one? What would you tell them? Tell your neighbor. What would you tell them? Be nice. What would you tell your little person? Let's see, Rachel. What would you tell them? Move it to the right. How many steps? Move 5 to the right. Hands if you agree with that. Did we move all those points 5 steps? Let's double check. Let's see, this one goes 1, 2, 3, 4, 5. This one over here is 1, 2, 3, 4, 5. This one, 1, 2, 3, 4. Yep, it looks like 5 steps, all those points. So here we go. Here goes what I want you to see. Notice here inside it was f of x minus 5, and then move 5 to the right. So tell your neighbor what's going to happen when we have x plus 5. X plus 5. What's going to happen to the original function? Mario, what's going to happen to the original function? Move to the left, 5 steps. 1, 2, 3, 4, 5. Move all those points to the left. Graph it and label it G of X. All right, we're going to stop right there, guys. Make sure you practice your transformation using the home plate from tonight. Enjoy your home plate. See you guys tomorrow. Bye.